ordering relative strength of van der Waals force compared to other forces. So in this example problem, it says arrange the following attractive forces in order of increasing strength. So increasing strength, we want to go from the weakest to the strongest. So notice that here it gives us more than just it gives us more than just the interactions between intermolecular forces, but also intramolecular forces like ionic, covalent, and metallic bonds. So here we're going to look. We know that London dispersion forces are the weakest of the van der Waals forces, and van der Waals forces, all of them, are weaker than the intramolecular forces. So we have to look for London dispersion forces to be first, and we see that it happens in A and D, not B or C. Dipole-dipole attraction is stronger than London dispersion forces, so that means it should be after in this problem. So B is out of the question, and C. So now we can work with A and D. So next is dipole-dipole attraction, which definitely works because this is a type of van der Waals force and it's stronger than a London dispersion force. So that works. Now we move to the next one and see if one of these answers starts to get wrong. So hydrogen bonding, and here it says covalent bonding, then hydrogen bonding. But we have to remember that hydrogen bonding is a very strong, particularly strong dipole-dipole attraction. So it's a little bit stronger than the other dipole-dipole attractions. So this would be it would be after dipole attraction, which it is, but it should be before covalent bond because a covalent bond is stronger because it's an intramolecular force. So D is out of the running as well. And as we can see, A is the only option that works because covalent bonds are less strong than metallic, and then ionic bond is the strongest bond even for intramolecular bond. So A is the answer to our question, and it also shows you in a nice way which forces, van der Waals forces, and also other forces, intramolecular forces, and in what order they go. So London dispersion forces, dipole-dipole, then hydrogen bond, then covalent bonds, then metallic, then the strongest is an ionic bond.